the replication. So that brings me to the one thing that may not be in your textbook, and the most latest version of the textbooks. And this is kind of the newest thing I would say that I've seen really make an impact on social psychology in a big way in the last decade or so. And that's something called the replication crisis. Anybody heard of the replication crisis before? So maybe you have, maybe you haven't. So let me tell you about what it is. Okay. So if you look at a social psych textbook, including your own today and many more going back from the 50s and 60s when social psychology first really was born, there are certain things we talk about as though they are true, right? So if people are doing this, then that happens. This is a causal relationship. It's been well supported. We have some studies on this. We feel like we know it and understand it well. It's been around for decades, right? But for reasons I'm going to talk about, these studies are not super well replicated. In other words, when you go to the published literature and you type in something like the Milgram study, there's not that many people doing it. And for that study, it's a little different because there are like ethical reasons it's not done today. But there's a lot of studies where you really can't find a lot of replications of the study. And again, I'll tell you why that's the case here in just a bit. And so there are things that we think we know that we may not know. And one of the ways this has been done, there's a guy named Brian Nosek at Virginia, and he put together a project. He's kind of a well-known social psychologist, and he spearheaded this effort where he got a lot of different people together that were interested in addressing this replication issue, and they were just curious. They took something like 100 or 20, I can't remember how many, famous studies in psychology, and they tried to replicate them just to see what would happen. And what they found is that most of them did not replicate. Right? So most of the time, when they tried to recreate these famous studies of these things that we feel like are foundational, well-known things in social psychology, people just couldn't find it. They couldn't replicate it. Okay, and that's kicked off a little bit of what they might term as the replication crisis. This idea that some of the things that we know don't replicate. Right? So this is really different than what you would see in physics. Right? If you're doing a study on gravity in physics, you replicate that 100% of the time, every time. Right? Unless you mess it up somehow. You drop a thing from a height, it gets the same velocity when it falls, every time. Psychology doesn't work that way. And part of it, again, is that we have a probabilistic causal determination. That's part of it. But it doesn't really work that way in psychology. And so the replications, they don't always happen, and they don't always work when they are tried, right? And then they often don't end up in journals. That's another thing I want to talk about. So let me get into it a little bit. So this is going to go deep in the weeds in a way that you may not want, or you may want. If you're interested in like behind the scenes, how this stuff works, that's what I'm going to try to share, right? And I'll start by saying I've been here 20 years. I'm full professor. I've been an editor at 2 different journals. I've reviewed hundreds and hundreds of papers. So I kind of feel like I know how the publishing industry and all that works pretty well. So let's start with the basics here. Let's talk about let's start with the journals, okay? So what is a journal, and what are they doing, and what role do they play? Well, our scientific work is distributed to other people through scientific journals, right? So that's starting to change a little bit. Now you'll see people make, like social media posts or YouTube or something like that. But by and large, 99.99% of the time, if you have a study and you want to get it out there to the world, you put it in a scientific journal. That's your goal as a researcher, okay? And if you don't put it out there in the world, nobody knows about it, right? It's just you talking about it to people you know, but it's not really a scientific finding unless it's been in a peer-reviewed scientific journal. So what do journals want? Well, first off, you should know that journals are for-profit businesses. They work and they exist to make money, primarily. And some are famously bad. Like Elsevier is a huge publisher, tons of scientific journals. They have huge profit margins, and they charge a fortune. We have journals here at NC State, engineering journals, where 1-year subscription might be $15,000 for the university, and that's 4 issues. I mean, it's ridiculously expensive, and that's what the journals exist for. They exist to make money. There are some movements afoot for things like open source publishing and more nonprofits, but they're still not the norm, and it's still that the most reputable journals are the journals that have been around a really long time, which are for-profit journals. So let's imagine you work at a journal, and it's a business. You need to make money. How do you make money? Well, the way you make money is by selling your journal to institutions. So you go around the country and you talk to librarians and you say, hey, we publish important work. Your faculty have to know about this work. You need access to this journal, Okay. Or you go to the faculty and say, hey, you need to demand that your library has this journal. You need to know what's going on. And you sell mostly to institutional libraries and things, right? Other things you can do, you can try to sell individual subscriptions, individual faculty, that they're usually a much lower rate. So individuals pay way less than libraries pay because the salespeople know that libraries have a lot more money, right? Institutional money. You can also do open source. And by the way, if you're ever browsing a journal and you see that the journal wants you to pay for access, please don't ever do that, because the person that wrote that article doesn't see a dime. They don't know you even paid for it. It only goes to the publisher, which has already got plenty of money. So don't do that. Better thing to do is email the author and just say, hey, can I have a copy of your paper? And 98% of the time, they'll write back and say, yeah, thanks for being interested in it. Here it is for free, right? So know that, first off. The journals are in the business of making money, right? They need sales. So how do they make sales? Well, they need to make sales. They need to argue that their journal publishes important stuff. So how do they argue that their journal publishes important stuff? Well, there's a metric that's usually used called impact factor. An impact factor is a measure of how many researchers are citing that journal, right? So imagine that you are you own the Journal of Applied Psychology or Journal of Personality and Social Psychology, and you want to argue to a library that they need to buy this journal. What you try to do is you say, well, look, this journal gets cited a lot more than other journals do. And the way that you show that is through something called an impact factor. So, anything above 5 would be pretty high. And it's kind of like a ratio of the number of journals that your journal is citing, so the extent to which people writing for your journal cite other journals, versus the ratio of people writing other papers and other journals are citing your journal, right? So the idea is if lots of people are citing your journal, you get a really high impact factor. And that lets people sell. So this is kind of the starting point, right? Journals want to sell their papers. They do it by demonstrating that they publish papers that lots of other researchers are citing, okay? So then what this creates is pressure on the journal editor, right? Because if I'm a journal editor and my journal needs papers published that lots of people cite, well, there's only certain kinds of papers that lots of people tend to cite, okay? Things that are more kind of out there and weird or wacky or have a lot of media appeal, these are things that people are more likely to cite than something kind of boring, right? Where do replications fall into this, do you think? Well, let's think about what a replication is. It's redoing somebody else's study that's already been published in another journal, okay? So Darley and Latine published a study showing kind of helping behavior and the bystander effect that we've talked about, okay? Let's say that I go today and you know what, I'm going to replicate this. And I go to my lab and I do it, and I spend a year and a half replicating the study and writing it up, and I send it to a journal and say, hey, look, I replicated Darley and Latine's study. The journal's going to look at this and say, yeah, so what? Why would we publish this? Because anybody citing bystander effect, they're going to cite the original work. They're going to cite Darley and Latine's 1970s papers. They're not going to cite your replication, right? They may in passing say, oh, by the way, other people replicated this if you're lucky. But 80% of the time, people don't really cite replications much. They cite the original work. And you want to get, as an author, you want to give credit to the people that came up with the theory, came up with the original study. They're the people that did the hard work here. And so you cite the original author. So a replication doesn't get cited. So a journal looks at it and says, you know what? If nobody's going to cite this paper, it's going to bring down our impact factor. And if our impact factor goes down, our reputation suffers. And if our reputation suffers, our sales suffer. Therefore, we don't want your replications. Keep them, right? We don't want to publish them. And that's usually what happens. They're just not that interested in it. So that's the journal side. Let's talk about the researcher side. So first off, how many people are aware of the different sort of ranks of professors? So assistant, associate, full professor. Anybody heard those terms before? A little bit, right? So how does it work? So the way it works is you, as a budding researcher, you go to graduate school, you get your PhD, and you go to try to get an academic job. The place you start is at the associate professor rank. They have different ones in Europe and England and those kind of things. But for here in the U.S., you start as an assistant professor. You usually start with a 5-year contract and the option to renew for 3 additional years. Okay, so you have a contract that says we're going to hire you for 5 years. We won't fire you in this time. But at the end of that 5 years, we're going to look at it. We're going to look at what you've been up to. And we're going to see if we want to keep you around for another 3 years. And at the end of that process, you go through the tenure and promotion process, typically speaking. Okay, So when you are on that first contract as an assistant professor, right, your job is not guaranteed long term. You have to produce lots of research. You have to be a good teacher too, but honestly, at a big research school like NC State or Chapel Hill or other big universities, they're going to look really hard at your research. And the reason is there's kind of a lot of good teachers in the world, but there's not that many good researchers in the world. So a big school like NC State or Chapel Hill or whoever, they're going to prioritize researchers, right? And that's the dirty secret of what you're paying for here. And my kids go to big schools too, so I get it as a parent too. So what you end up with at big schools are people that are very good at research that may be terrible at teaching. So if you've had some really terrible professors, that's probably why. They're probably hella researchers, right? They're really good at that part of it, and they just show up in the classroom and muck around, and you're on your own. But there's a lot of pressure. So here's what happens. So if you at the end of that 7 years, 8 years, if you had produced a lot of research, and a lot of people have cited that research, you go to the university and essentially you go through this tenure process. It's a year-long or 9-month-long process where you get letters from people outside the university that know about your work. They talk about the quality of it. You make a case that your work's important. And if you get tenure, so it's voted on by your department first. They say, we support you for tenure, and there's a count. And then it goes to the college, and then it goes to the university, then it goes up to the whole system level. And if everybody there agrees that you get tenure and you become an associate professor. Well, what does tenure do? Tenure makes it very hard for you to get fired. It gives you job security for life, so long as you don't mess it up somehow, right? Like if you're not harassing students or getting arrested and whatnot, all these things, you're probably set for a long time. So it's a great position to be in. Tenure is the goal. It's 100% the reason that people want to work in a university, right? These what's called tenure and tenure track jobs. So okay, so that's your jam. You're going to go to grad school. You're going to get your degree. You're going to go work in the university. You're going to be an assistant professor. You're going to try to get tenure and promotion to associate professor, which is a really good job security, right? How do you do that? Well, the way you do that is by showing that you're competent in teaching, but really by showing that you're a good researcher. And the way you do that is you put out a lot of papers that are published in peer-reviewed journals, that are published in high impact factor journals, and that people cite. And the cycle, so citations come later, right? Your paper will be out there for a year or two before anybody cites it, then more and more and more. So there's a lot of pressure, and you can't really look at the citations very closely to see if somebody's doing good work. What you look at is the quality of the journals they're publishing in, okay? And the way you know that is impact factor, because it takes too long for citations to come to know if that work was any good. It could take 5, 10 years. But the impact factor you know today, right? So we can look at that. So what does this mean? Well, from a researcher perspective, you are strongly motivated to publish work that's going to make it into a top-tier journal with a high impact factor, right? The way that, so keep in mind now, what that means is that the journals that you're going to be applying to are the journals we've already talked about that are just not interested in replication, right? Nobody cites replications. So as a researcher trying to get tenure, right, you would be kind of foolish to do a bunch of replication studies because the chances of those making it into really good journals is virtually zero, okay? So the point of this is the whole system is set up to discourage replication, right? From both the researchers even trying it and from the journals publishing it. Both people don't want that. There's no incentive to do that. There's no reason to do it, and there's a disincentive to do it because you've kind of wasted your time when you could have been doing something more novel that's going to be in a high impact factor journal. Okay, everybody with me so far? Okay, so this is one reason that we don't see any replications really, or not many replications. Sometimes people that already have tenure, they'll do them, or just for curiosity, or they'll do it for like a student project, just kind of getting your feet wet with learning research, things like that. But they rarely make it into top journals, and there's not really a good incentive to do it. Okay, so this is the reason we have very few replication attempts to begin with. We also have a couple of other issues that get at the replication crisis, and just more generally are a threat to the scientific validity of our field, okay? And I'll talk about those as well. There's something called the file drawer problem. And what the file drawer problem is, it's a situation where a researcher does a study, and these things take forever. It could be a year plus of work on a study and lots of people involved, lots of time, lots of money sometimes. And you get to the end of the study and you analyze your data and you look at the results and you decide, you know what, I'm not going to try to publish this. And it's called, you stick it in the file drawer and you forget about it, okay? So that sounds weird. Like, why would anybody ever do this? So what causes the file drawer problem? What do you think people might look at in their data when they decide, forget about publishing this study? What do you think might cause somebody to do that? Yeah. Okay, yeah, so it's something weird, right? So your hypothesis is that violent TV causes aggression, and what you find is the opposite. Seeing nonviolent TV causes aggression. It doesn't make any sense. That's a very good candidate for the file drawer. Why? You can have a hard time publishing that. People are going to look at it and say, this doesn't make any sense. You probably messed up your study. It's probably no good. Therefore, we're going to reject it. So essentially, it's researchers anticipating rejection from a journal and never sending it in to begin with, right? Because that's a long, hard process to get something published in a journal. It takes way more time than you might think and more effort. So it's easier just to forget it ever happened. Just throw it in the file drawer and be done with it. It happens in two big cases when it happens. Number one is you find the opposite of what you thought you would find, okay? And number two, you find nothing at all, okay? So my theory is that violent TV causes aggression. Turns out it didn't in my study. It just didn't work. Just flat out did not work. That could mean that and so what you could do is you could try to publish that, which would be an interesting finding and would advance the field. But the problem is we don't know if it's a bad theory or a bad study, okay? When your study doesn't work, and it usually doesn't work, by the way, I've done, God, I don't even know, like most of my studies don't work, right? And that's the way it goes. It could be a bad theory. It could be that violent TV does not, in fact, cause aggression. Or it could be that you just messed it up. The video you showed wasn't very good. If you'd had a different video, maybe it would have worked, but you didn't. You picked this other video. The way you measured aggression wasn't very good, right? You don't really know if you messed up the study or if the theory's bad to begin with. And so it's very hard to publish null results. Occasionally a journal will do like a special issue where they publish nothing but null results, but that's very, very rare. Maybe once every few years for a lower end journal, but never in a high end journal. So there's a strong bias in the literature for studies that work, where the hypothesis is supported. And if you go and pick up a modern journal and a top tier journal, I can almost guarantee you that every single study published worked in some way, right? Now, what does this do? Well, this has a strong biasing effect on our field, okay? So the way science should work is you have lots of people replicating lots of studies, trying little variations on a study. All those studies get published so that anybody curious about this, like a textbook author, let's say, could go and find 20 studies on the bystander effect, and they could see that 80% of the time it doesn't work, and 20% of the time it does. That would be a very accurate read on this particular phenomenon. And the textbook authors could write and say, well, you know what, like most of the time we don't really see this, but occasionally we do, and so, you know, maybe this is a thing, maybe it's not. They can be very nuanced about their language. What happens instead? Well, 20 people did a study on the bystander effect, and only, let's say, 4 of them worked. Which 4 are going to show up in the literature? When you go to the literature, you're going to find 4 studies that say the bystander effect is real, it works, it's a strong effect, this is a real thing. And you're going to see 0 studies that say the opposite. You're going to see no studies at all that say this didn't work. Okay, when in reality, 16 of the 20 studies found nothing at all. Like, this is not a real thing. So you get a very biased view of kind of what we know, right? And this is the way that as I've gotten kind of older and longer in this, you start to really question some of the stuff you see because you don't know why you're seeing it. You know, maybe it's a real thing. Maybe we see it a lot. Maybe we don't. And that was kind of what's shocking about this replication crisis study where they took like 100 or whatever studies in psychology and tried to replicate them. Most of them didn't replicate. And the reason that was so shocking is because if you go to the literature, all you see are studies where it works, like study after study after study after study where this is a real thing. But when you try it yourself, it doesn't work. I had this similar experience with, we'll talk about social cognition, the implicit association test. Some of you are probably familiar with that. And you read all these studies about how bias on this or that or the other predicts these or those sort of outcomes. So I was like, you know what? I had a study where I was sure it would work. I was looking at bias based on physical attractiveness, right? So I was interested in whether or not physically attractive people on paper would get more job interviews than non-physically attractive people, and I had a whole study and I had everything controlled just so. And I went on the internet. There was a website like a long time ago called Hot or Not, where people put their photos and other people would rate how attractive they were. So I used that as like my pilot test to pick out like, okay, everybody thinks these people are attractive, these people are not. Pilot did the whole thing. And I used this implicit association test to look for people that were more biased based on physical attractiveness. And my hypothesis was, well, people that are more biased based on this test, right, should show a stronger preference for the attractive job candidate. Makes sense, right? I mean, we know that in general, there's a bias in favor of attractive people. I read dozens of papers about this test and how well it worked and how it covered all these unconscious biases, and you still see a lot of talk about this today. And I did the study, and of course, nothing, absolutely nothing, like zero relationship whatsoever here, okay? So what did I do with it? Well, I stuck it in the file drawer, and I was just going to my desk the other day, and it's still in there. Like 12 years later, it's still in that file drawer. And it never got published. It never got presented at a conference. Nobody knows I did it except me and like 3 grad students that helped me with it. And that happens a lot. And the reason is because I know I can't publish that paper. Because if I try to publish that paper, the reviewers are likely to say, you know what? I think you messed your study up. I don't think you had a good manipulation, or I don't think you measured this the right way, or I don't think you did the, there's like a million little ways people can criticize your study, okay? And it's just hard to publish it, so it ends up in the file drawer. Okay. All right, so that's a little bit about how we can find biased results in our literature. Our literature is not a representative sample of all the studies that are done. It's very heavily biased toward ones that are successful, where the hypothesis is supported, okay? So you can imagine a phenomenon where a large group of people, imagine something where tons and tons and tons of researchers are looking at this literature on these implicit association tests and these biases. And there's maybe like in a given year 150 studies using this measure. Well, what happens is if you look the following year, there's now something like 20 studies, and they all show that, yeah, more biased people are more likely to try to do this or that or the other. And you don't see those other, 70 papers. Most of the papers find nothing. You don't see it. So you end up with a very skewed look at kind of the real state of affairs, right? It's not that accurate sometimes. Now, I still think the scientific method is the best way to do it, but I recognize there's a lot of limitations on it. So first off, let's talk about why studies don't work, right? And we'll talk about replications in particular, but it could be any study. There's sort of 3 different kind of reasons that your study might not work. The first study is just a small effect. So we talked about probabilistic causation, and that gets at this notion of strong and weak effects, okay? So imagine something that like this study I just did with you, this study about the Mississippi River, that's a very strong effect. That anchoring and adjusting effect is very strong. I've seen it every time I've taught this class. It shows up, it's significant. I get much bigger estimates for the people that see 2,000 miles and 500 miles. It works really well. It's a very strong effect, okay? But there's a lot of stuff in social psychology where the effect is very weak, right? And the effect is so weak that sometimes you see it, sometimes you don't, okay? And that's one reason studies don't replicate. If it's a very weak effect, you don't expect to see it 100% of the time that you do the study, right? It depends on the study. You may see it only 5 or 10% of the time. So just by its very nature, some effects are just weaker, right? You're just not going to see them all the time, okay? And if they're weak effects, you don't expect them to replicate 100% of the time. You expect them to replicate every so often. And that's just the nature of the way science works, right? It's just, you just don't see it all the time, okay? The other thing is an advanced methodological concept called sampling error that most people don't understand well at all. I actually have a YouTube video if you're interested in hearing me talk about sampling error to a bunch of graduate students. You can go to my YouTube channel and watch it. But essentially what sampling error is, it's a statistical issue involved with your sample. So when we do studies, ideally we would have a very large, very representative sample, or multiple samples around the world or whatever. What we have in reality is one sample, okay? And we don't know how representative that sample is. We hope it's representative, but we don't know. And so sampling error is basically the extent to which your sample is kind of squirrely, right? There's something weird about your sample. You just happen to get a bunch of people in your sample that are of a certain way. So let's imagine that you're doing a study on aggression and TV violence, and you randomly recruit undergraduates from NC State, and they come in, they don't know what the study's about. If you've only got, let's say, 20 people or something like that, by luck of the draw, you may have got 20 people that are maybe say something like just really disagreeable and kind of hostile to begin with, right? A personality characteristic. But you don't really know that, right? You don't really know that. And so maybe your study has an effect based on sampling. Or maybe the opposite happens. Maybe you get people that are just really agreeable, that are just very, very much, turn the other cheek kind of people, very agreeable people, easygoing people. And in that case, this whole aggression effect just doesn't show up with those kinds of people. Well, you don't really know why it didn't work. You just know it didn't work. And that's what we mean by sampling error. It's the extent to which your sample is not perfectly representative of the broader population. And smaller samples are never going to be perfectly representative, right? There's going to be some dimensions where they're just a little bit different. And you can see that we can do simulation studies and stuff through software that show this really well. And the last thing I've already talked about, selectivity in publication, right? People just don't publish replications, and they don't publish null results, and they certainly don't publish replications with null results. That's something they just don't do, right? So we end up with this replication crisis. All right. Anybody have any questions about the replication crisis? Again, it's all kind of, it's very deep dive, grad school level stuff I went into here, but it gives you a little indication of what's happening, right? What people are doing and why and what the motivations are. And it leads to this place where maybe we don't know everything we think we know, right?